Okay, stats. This is a short little project that goes with section 7.1, the confidence intervals that we've been making. This is the data that we collected like at the beginning of the year. And I've got all of you guys on here. The three bottom ones are you Lawrence kids, and then Blue Hill, you guys are top. I've got 4 columns here, and we're going to do stats, or there's one question that goes with each of these 4 columns. And the first one we'll do together, and that will just kind of like, number 2 is similar to that, number 3 is similar to that, 4 is similar to that. So if I do number 1 with you, you should get the idea of what you need to complete. And yeah, here we go. Number 1 has to do with the height column. So we're looking at the proportion of, and I have to apologize, when I originally did this project years and years and years ago, I only had seniors in the class. So we're going to change this. This is not seniors. This is the proportion of stats kids. Okay, or stats students, I guess. We're looking for the proportion of stats students who are taller than 5'4" or 64 inches. Now, taller than does not include 64 inches. So I'm going to look here, and we're looking for just the people who are taller than 64 inches. So not Jayton, not Haley. Carson, you're taller than 64 inches. Jalen, you're taller than 64 inches. Jake, you get to be included. Kyle, Libby, Luke. Chase is a yes. Claire is a yes. Connor is a yes. Daniel, sorry, you are a no. James is a yes. Connor is a yes. Clay is a yes. Maddie is a yes. So we've got 3 people that we're excluding, right? And we're looking at proportions. So when we're doing proportions who are taller than, that would be, I think there's 16 of you total. 13 out of 16. Let me move that over. Okay. For part A, we're trying to find p hat, q hat, and n. So n equals p hat equals q hat equals, just write them down like this. Q hat, okay? N, there's 16 of you total. P hat, this has to do with our sample. Anytime we're talking about p hat or q hat, this is according to our sample. So 13 out of 16 are taller than 64 inches. 13 out of 16, hold on, I need a calculator. 13 out of 16 is 0.8125. 0.8125, okay? That means if I subtract Q would be 0.1875 is what my Q is. So we'll use those numbers for P hat, Q hat. Now, it is not fair for me to say that 81% of all stats students everywhere, or 81% of all high school students everywhere, if that's my population, 81% is greater than 64 inches. Like, that's not fair for me to say exactly that percentage. So rather than doing that, I say somewhere between this number and this number are taller than 64 inches. Okay, and we have to find that by doing the margin of error. Okay, and the margin of error is z of alpha over 2 times the square root of p hat q hat over n. What? No. Okay. They want, and they don't tell you for the margin of error. We got to look down below here. We want a 90% confidence interval. So we're going to use the 90% number for our z value for margin of error. 90% was, I got to remember, 1.645. It's either, I think 1.96 was 95. I don't remember. 1.645 and 1.96. 1.645 was 90%. Okay, sorry, I'm going to make you dizzy. Okay, so that's the z that I'm going to use. So when I'm doing my error, 1.645 is the z times the square root of 0.8125, 0.1875, and my n is 16. Okay, now, with only 16 students, our margin of error might be a little bit bigger than normal. Like, usually I say like less than 5%, but our margin of error might be a little bit bigger than that just because we only have 16 students that we're serving. So let's see what we've got. 8125 times, I have my dumb calculator again. I forgot to grab my other one. 875 divided by 16. And I've got a helper. She's sleeping, so if you hear her snoring, that's the deal. And then times 1.645. I get, ooh, yikes, 0.16, we'll round it, we'll go 0.05. Okay, that means my margin of error as a percentage is 16.05%. That is a hefty margin of error. Like, that's a lot, right? Because we have to remember that, like, my number here in the middle, we have to add this side and this side. So that's like a 30% gap for our deal here. Now, also, well, I guess no. Just the fact that my margin of error is so large, that is due mostly because my 16 is such a low number for a sample. Typically, we're going to be sampling 50, 100 kids, whatever, right? Okay. But I didn't want to have to deal with all that data, so we're just doing 16, so my margin of error is going to be bigger, okay? C says find the 90% confidence interval estimate for the proportion of seniors who are taller than 5'4". So all I do is use this 8125, and I add and subtract 16% to it. Okay, so 0.81, actually, I'm just going to put it as a percentage. I don't care if you do percent or decimal. So if you want to do 81.25 and add and subtract 16.05 and write it as a percentage or write it as a decimal, I don't care which one. If I add, that is 97.30%, 97.3%, and I can't subtract that. Or maybe I can. Yeah, I can. 0.20, 65.20. 65.2%. So 65.2 and 97%. That is my confidence interval estimate. Okay. All right. And we're going to do the interpretation down here at the bottom for part D. So in your own words, write out the explanation for your answer in part C. So I said before that you need to include a couple different things. Okay. So things that you need to include and don't necessarily have to be in this order. How confident are you? Okay. Another thing that you need to include is the percentage interval. So list out what the interval is. So you need to list out this thing right here, what we just found. List out the interval. Okay. Another thing you need to include is for all whatever it is you're talking about. Okay. So like for all students, rather than, yes, I'm just basing this off of my sample, but if I were to survey all kids, this is what would happen. And then list some sort of context of the problem. Okay. All right. So I'm going to write out what I would put for this explanation. We'll see if we covered all of our stuff. So I would say how confident are we? We are 90% confident that if we survey, let's say our population is all stats kids. Between 65.2% and 97.3% would be taller than 64 inches, or you can say 5'4". Okay, so how confident are we? 90%. The interval right here for all, that if we survey all stats kids, context of the problem, taller than 64 inches. So I've included everything. Okay, not necessarily in the order that I listed them here, but that's how I usually would say that. Okay, you have to include all of those elements in your explanation. Okay. Hopefully that made a little bit of sense. This just goes back with what we were doing in section 7.1, but this is just like for our class data, so I think it's kind of fun to do. The next one is going to be pulse rate. So seniors who have pulses, but this one is less than 65. Now keep in mind, less than 65 does not include 65, so 64 and down. And you're going to find out P, Q, and N just like you did before, but now you're doing 95% confidence, so make sure you're using the correct value of Z. It's not going to be 1.645. The next one is looking at proportions of seniors who have birthdays in the first half of the year, so January to June. You're going to figure out how many or what percent of people are January to June. So like September is not included in that. Sorry, Jayden. Haley, you get to be included, etc. You go on down, okay? And then I think the fourth one is exact age, and that's at graduation. So, like these dates right here, like Jayton will be 18.612 years old at exact day of graduation. Okay. So that's how that works. Keep in mind or fix this. It's not seniors, it's stats kids or stats students. So fix that for all of these because it's not just seniors. There's 3 of you that are juniors in here. So fix that for each one, especially when you're doing your explanation. And hopefully that is okay. All right. So use the rest of the time in class to work on those last 3, and that is all.